Today we're going to learn how to do integrals that can be evaluated using trigonometry or replacements. They do look similar to arc functions. Usually they contain one of these three square root functions. In this case, a is the constant and u is the variable. In each of these three square roots they can be replaced using a trigonometric equation. In the first one, you can say that u is equal to a sine theta. Second one is u is equal to a tangent theta. And then the final one, u is equal to a secant theta. So when looking at a integral, you need to find which square root function it has and then replace accordingly and use a triangle to replace the remaining parts. First example, we have square root of 1 over x squared times square root of 9 minus x squared dx. In this case, right here we have the first one, which is a squared minus u squared. So it would be u, which is x, is equal to 3 sine theta. Dx, take the derivative of that to replace the dx. Since this right here will replace the x, we need to find a replacement for the dx, equal to 3 cosine theta d theta. And now to find a replacement for the square root, we need to draw a triangle. Not quite a right triangle, but we'll make do with that. Since we know that x is equal to 3 sine theta is equal to x over 3, opposite over hypotenuse, 3x. And now we need to solve for the other side, which you could call this a squared plus x squared equal to 9, 3 squared. And then using algebra, a is equal to the square root 9 minus x squared. We know we matched up with the correct trig function because these match. So 9 minus x squared. And we would probably want to use the cosine function to find a replacement for this so that we're not getting an extra variable in. So, since cosine is adjacent over hypotenuse, we know cosine theta is equal to the square root 9 minus x squared over 3, which is equal to 3 cosine theta equals the square root 9 minus x squared. So now we should have all the parts necessary to replace this integral, which we can't solve without any substitution, with the trig functions, which we should be able to. Okay? So it's still the integral. We know that dx, 3 cosine theta d theta, x squared, well, we know that x is equal to 3 sine theta, so x squared would be 9 sine squared theta, and the square root of 9 minus x squared is right here, 3 cosine theta. Okay? 3 cosine theta cancels out, so we are left with the integral of 1 over sine squared is the same as cosecant squared. So we can bring the 1/9 out front. Cosecant squared theta d theta. And now that integral can be evaluated. The integral of cosecant squared theta is negative cotangent theta. So negative 1/9 cotangent theta plus c. Now we can't leave it with thetas, but we do have some options to replace it with. So probably the easiest would be, you know that tangent of theta is equal to opposite over adjacent, x over the square root 9 minus squared, and since cotangent is the inverse of that, 1/9, flip that, square root 9 minus x squared over x plus c is the answer.